Hello everyone. Okay, so in this video we're going to be going over Bernoulli trials and the multiplication rule for independent events. So first of all, what is an independent event? So two events are said to be independent if the probability of one happening, the probability of one doesn't affect the probability of the other. So, for example, you rolling a 4 on a dice will not affect the probability of you flipping a heads on a coin, right? But however, like say you not studying for your test will affect the probability of how well you do. So they are not independent events. If two events are independent, right, the probability of both of them happening at the same time, so probability of A and B happening, so the two events happening at the same time, you multiply the two probabilities together, probability A times probability B. So these questions are asked in context with Bernoulli trials. In Leaving Cert Ordinary Level, you don't need to delve into Bernoulli trials per se, but you need to recognize the type of questions. So Bernoulli trials just means you list out all. So you have just two probabilities: success and failure. You repeat the event or the experiments or trial a couple of times, and then you have different outcomes. You have to kind of list all the possible outcomes you could have. So you'll make more sense when we do the question. So 2014 Leaving Cert Ordinary Level Paper 2 question 2. So when taking a penalty kick, the probability of Kevin scoring is always 3/4. Kevin takes 3 penalties. What's the probability he scores exactly twice? So this is my Bernoulli trial here, because the probability he succeeds is 3/4. The probability he fails, so the probability he misses is going to be 1/4. So if he scores 3/4 times, he misses another quarter of the time. The key thing with Bernoulli trial is, or these type of stuff, is we need to list out all of my possible events here. So he scores exactly twice. So he doesn't score once, he doesn't score 3 times, he scores exactly twice. But when does he score them goals? So he could score the first 2 times and miss the last time. He could miss the first one and then score the last 2, and then finally he could score, miss, and score again. So now I want to find the probability of him scoring and missing, the probability of missing, scoring, and scoring, or the probability of scoring, missing, and scoring. So him scoring and missing, in this case, they are independent events. His probability that he scores is always 3/4. That will never change, no matter how often he misses. So these are independent events. So the probability of scoring, and missing is the probability of scoring times the probability of scoring times the probability of missing. Probability missing, scoring, probability missing times probability scoring plus the probability of scoring, and then the same thing here, the probability of scoring plus the probability of missing plus the probability of scoring. So probability scoring is 3/4. So 3/4 times 3/4 times missing 1/4. Add that to probability of 1/4 times 3/4 times 3/4 plus probability of scoring 3/4 plus the probability missing 1/4 plus the times the probability of scoring is 3/4. Put all of that in your calculator. So 3/4 times 3/4 and 1/4. 3. When you put all that in your calculator, you are gonna get 22/64. So he has a 22/64 chance to score exactly twice. Alright. Let's move on. Sorry. And let's move on to the next question here. So Kevin takes 5 penalties. What's the probability that he scores for the first time on his 5th penalty. So let's look at that now. So he scores on the 5th penalty. So he scores on the 5th. That means he missed, and then he scored. So he scored for the first time on his 5th penalty. So these are independent events. So it's probably he misses. Probably times the probability he misses. Times the probability he misses. Times the probability he misses. Times the probability he scores. That's going to be 1/4 times 1/4 times 1/4 times 1/4 times 3/4. That is going to be equal to power of 4 1/256 times 3/4. So the probability he misses, and then scores on the 5th go is 3/1200. No, 1024. Right, so let's look at more examples now from the Leaving Cert paper. So this is from the 2021 Leaving Cert paper, paper 2, question 2, part A. At a stall at a fun fair, the probability of knocking a coconut off its support is 0.34. What's the probability of not knocking the coconut off its support? So what's the probability of failing? So the probability of not doing it, right, the probability of not knocking the coconut off, so I'm going to say the probability of failure here, I'm going to say F for failure, is going to be 1 minus 0.34, which is 0.56. No, it's not. 66. 0.66. So the probability he fails is 0.66. Now it's going to lead into my Bernoulli trial here. David is given 3 attempts to knock the coconut off its support. What's the probability that he knocks the coconut for the first time on his 3rd attempt? So he fails. So he missed. So he failed. He failed, and then he got it on the 3rd attempt. So these are independent events. So the probability of knocking the coconut is always going to be 0.34. It doesn't say it changes. So it's going to be the probability he fails times the probability he fails times the probability he succeeds, which is going to be 0.66 times 0.66 times 0.34. Which is 0.1481104. It says round to 3 decimal places. So it's going to be 0.148. That's the probability he fails and he knocks the coconut off correctly the first time. Right, in a large population, 1 in 8 of the people play tennis. 4 people are chosen at random from the population. What's the probability that the 4th person chosen is the only one to play tennis? So this is from the 2020 Leaving Cert level paper. This is paper 2, question 1. So in a large population, 1 in 8 people play tennis. So the probability of people play tennis is 1 in 8. 4 people are chosen at random from the population. What's the probability that the 4th person chosen is the only one to play tennis? So therefore, the first 3 people don't play tennis. I'm just going to do a little T exclamation mark to indicate they don't play tennis. And then the last one plays tennis. The probability of not playing a tennis is 7/8. I'm going to multiply that by 7/8. Multiply that by 7/8. And then I'm going to multiply that by 1/8. Put that in your calculator. 7/8 times 7/8 times 7/8 times 1/8. That is going to be 343 all over 4096. So probably don't play tennis, don't play tennis, don't play tennis. The last one does play tennis. Is 343 over 4096. 3 people are chosen at random from the population. What's the probability that exactly 2 of them play tennis? So again, let's list out all of our outcomes. So the first person doesn't play tennis, and the last 2 do. Then the first person can play tennis, the second person mightn't, and then the last person can play tennis. And then finally the last one is last one is the first person plays tennis, second person plays tennis, and then the last person doesn't play tennis. So let's shove all of this in. So probability of not playing tennis times the probability of playing tennis times the probability of playing tennis plus probability of playing tennis times probability of not playing tennis times the probability of playing tennis plus the probability of playing tennis times probability of tennis times probability of not playing tennis. So probably not playing tennis, 7 over 8 times 1 over 8 times 1 over 8 plus 1 over 8 times 7 over 8 times 1 over 8 plus 1 over 8 times 1 over 8 times 7 over 8. Put all of that in your calculator. I'm going to get a massive number here, I think. And you're going to get here probability of exactly 2. It's going to be 21 over 512. That's my answer there. 21 over 512. Now finally, this is our last question now. This is from the 2019 paper. So you see, this comes up fairly often. I think in probability, Bernoulli trials is the one that kind of appears the most often. So in a population, the probability of a person having blue eyes is 0.7. It is. So one person is chosen random from the population. What's the probability they don't have blue eyes? So probability don't have blue eyes. So I'm going to say B apostrophe for no blue eyes. That's going to be 1 minus 0.7, which is 0.3. So there's a 0.3% chance a person doesn't have blue eyes. So 2 people are chosen at random. What's the probability they both have blue eyes? So again, 2 people are chosen at random. So I'm looking for blue, blue. These are independent events. Me having lovely ocean blue eyes does not affect the probability of someone walking down the street has blue eyes. So it's going to be, what was the probability? 7. So 0.7. So these are independent events. So probability of blue times probability of blue, which is 0.7 times 0.7, which is going to give me 0.49. So the probability of picking 2 people at random, right, and they both have blue eyes is 0.49 or 49%. My last one, 3 people are chosen at random. What's the probability exactly 2 of them have blue eyes? Probably that exactly 2 have blue eyes. So again, probability blue, not blue, blue, plus the probability of not blue, 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 plus what's the other one? Probability of blue, blue, and not blue. Alright, so this one here, that's going to be probability blue times probability not blue times probability blue. So that is going to be 0.3 sorry. Probability of blue is 0.7, so 0.7 times 0.3 times 0.7. Add that to 0.3 times 0.7 times 0.7. So probability no blue, blue, blue. Plus the probability of blue, 0.7 times 0.7 times 0.3. So I have here 0.7 times 0.7 times 0.3. 147 over 1000 plus 0.7 times 0.7 times 0.3 that plus 147 over 1000. That in total is going to equal to probability of exactly 2 blue eyes is equal to 441 over 1000 thousands. So that's the final question there. So they were 3 exam papers, and they are exactly how these questions would come up in your exam. So it's really important that you know how to calculate 2 events happening at the same time if they're independent. And also you have to recall, you have to recognize, you have to list out all the possible outcomes we could have, because it says exactly 2, but that could be in any order. That's where the Bernoulli trials comes in. And I hope this video was some help, and I'll catch you guys later. Bye.